All right, so we are going to still be talking about the sinusoidal functions, and we'll talk about the amplitude and the midline and the period some more. But we're going to take that a step farther and actually write the equation for the graphs. But we need all the stuff you learned the last couple of days to be able to do this as well. So before we really get started on what these things are, we're going to draw little baby parent functions over on the side here. So this one is going to be sine of theta. So the sine graph is going to oscillate, the y is going to oscillate between -1 and 1. Do you guys know what the period of sine is? Just plain old regular sine? It's 2 pi. So sine completes one cycle in 2 pi. And so I guess the important parts of the sine curve happen at the beginning of 0, at pi over 2, pi, and 3 pi over 2. So that's the max, the mins, and the middles of the sine curve. The parent function anyway. Okay, do you guys remember what the sine of 0 is? Like no rotation, what the y coordinate is? 0. What about pi over 2? 1. Pi? 3 pi over 2? And then a full rotation? Also 0. This is what one period of sine, the sine curve, looks like. So now today we'll take that little sine curve and we'll stretch it or compress it, or I should say dilate it, and translate it, so shift it around to make it a different function, but it starts off with the same parent function. So that's one period of the parent function of sine, and then we're going to draw a period of the parent function of cosine. It also is going to oscillate between -1 and 1. It has the same period. And this is also where the important parts of cosine are, the max, the mins, and the middle of the graph. So do you guys remember the cosine of 0? Cosine of 0 is 1. The x-coordinate at 0 is 1. Pi over 2 is 0. Cosine of pi is -1. And then 0. And then 1. Oops. Alright, so that's one period of the cosine of theta, the parent function. So it's the one that looks like the Texas Longhorn. And again, it's going to be dilated and translated, and they both can be reflected also. But that's where they start. Okay, and so a midline, like we talked about yesterday and the day before, it's going to correspond with a vertical translation. So the midline of the parent functions is 0, but if that is shifted up 2, that's going to shift the midline up 2. If it's shifted down 4, that's going to shift the midline down 4. So they are always correlated. All right, and then the amplitude is going to be affected by a vertical dilation. So a vertical dilation would either make the sine or cosine taller or shorter, and that is going to affect the amplitude. And then the period would be affected by a horizontal dilation. So it could be narrower or it could be wider depending on the horizontal dilation. All right, and so if we were looking at this generic form of sine and cosine, and without looking at this down here, which one of these letters, A, B, or D, do you think is the midline, if that's the vertical dilation? A doesn't do I'm sorry, you answered the right question. I said the wrong thing. The midline, sorry, is a vertical translation. Which one is that going to be for a vertical translation? D. So D is going to be the midline, which is what this says. All right, what about the amplitude of this vertical dilation? That's going to be kind of be A. So this technically should be the absolute value of A, represents the amplitude. The amplitude is always positive. So the amplitude is a positive value. Now A is not always positive, but if A was like, if this was like -2 sine whatever, you would say the amplitude is 2. The amplitude is always the absolute value of A. What do you think happens if A is negative? Yeah, it flips it upside down, yeah. So whenever that number in the front is negative, there is a reflection over the x-axis. All right, so a negative sign is going to look like that. It's kind of hard to draw. And then a negative cosine is going to look like that. So it's like a horns down Texas Longhorn. Sorry if there's any Texas fans in here, but that's how I remember it. Okay, and then if we're thinking about a horizontal dilation that affects the period, that's going to be something that's multiplied on the inside. And if you guys remember, for the horizontal dilation, the factor it's multiplied by is 1 over whatever it is. And so because the original period of sine and cosine is 2 pi, to figure out the period of a translated function, you do 2 pi divided by whatever that coefficient of theta is. Okay, and we're going to use this equation in different ways. All right, so here we go. This one, there's kind of a crutch. Like, they give you a whole lot of information. This is stuff that we talked about before. They told us what the midline is, what the amplitude is, and what the period is. So one cycle of sine occurs between 0 and pi, so that's the period. And so they want us to now go and figure out what A, B, and D are. Now, I personally like to start with the midline, but you can start with any of these. But the midline, to me, is the easiest to see. And so the midline is going to be associated with D. And it tells us the midline here is 3, so that means that D is 3. All right. The absolute value of A is always going to be the amplitude. And it tells you the amplitude is 6. And so, wait, hold on. Before I say that A is 6, let's hold on a second. Does this shape look like the regular sign or an upside down sign? That's a regular sign, so then A is positive 6. If it had been graphed upside down, then A would be negative 6. All right, and then for B, so to find B, we're always going to use the equation that the period is equal to 2 pi divided by B. And so we have to set up like a little baby equation. And so it tells you in this problem that the period is pi. So pi is going to equal 2 pi over B. And there's like a super quick way to solve this for B, or there's a longer way. It doesn't matter. Does anybody know the super quick way to solve this for B if you have a situation like this? Say it again.
Multiply b on both sides.
Okay, that's the algebraic way, and we'll do that. So we're going to multiply by b. And then what would you do to solve it for b? Divide by pi. So b is 2. That's the algebraic way. Let me show you the quick way. So when you have a situation like this, which you will over and over and over today and tomorrow as we do these problems, you can just switch. So if pi is equal to 2 pi over b, that means that b is equal to 2 pi over pi, which is the same thing we got here by solving it algebraically. It's just a shortcut. And if you want to do it algebraically, you can. But I personally like the shortcut. B is just going to be 2. Both ways, however you want to do it. All right, so the next one, they didn't give you very much information. I actually think we probably should have this given to us. So we're going to write an expression for f of theta. So I'm just going to give you the generic form, and we're going to figure out what A, B, and D are. All right, D is always associated with the midline. What is the midline of this graph? 3, good. All right, and A is either going to be the positive or negative version of the amplitude. Now, this is a positive version of sine. So it's going to be the positive version of the amplitude, which is also 3. Okay, and then B usually takes some effort to figure it out. What is the period of this graph? Pi. And that seems to be a pattern throughout these examples, but that's okay. I'm still going to pretend like we haven't already done this. The period is equal to 2 pi divided by b. So just exactly like what we did. The period is pi, so pi is 2 pi over b. So b is 2 pi over pi, which is still 2, just like it was in the previous problem. All right, so we have all the things, and they want us to write the equation for f of theta. So I'm just going to take my A and put it in for A. I'm going to put B in for B and D in for D. So that's the equation for that graph. Okay, are y'all okay? All right. The next question is something that you actually might see on the ACT. So we have a graph, and it doesn't tell us if it's sine or cosine or whatever, but they want us to identify the period and the amplitude of the graph. So what do you guys think for the period? It's going to be pi again. So this is one cycle of negative sine, actually. That you don't have to know that to do the problem, but the period is pi, so you can mark out C and D. And then what about the amplitude? 2. Good. That's the distance between the midline and the maximum or minimum is 2. So, like I said, I think I told you this before, the next time you guys take the ACT, you'll probably get at least one more question, right? Just on these graphs. Okay, and then example 4 is a lot like ones we did on the previous lesson, but they're taking it up a notch. So we still have to find the midline, the amplitude, and the period, but then we have to put them into the graph. And so we have a function that will say this is 0, and then, well, we can draw an axis if it's 0. All right, so up at 6, we have a maximum. All right, and then the next minimum is at pi over 2, negative 4. All right, so we have this kind of situation. All right, and then it tells us all of these choices are cosine graphs, and it makes sense. A cosine that hasn't been shifted horizontally, the maximum is on the x-axis, which is what happens here. All right, so what would you guys say the midline is? And you actually probably can just cheat, but it's definitely 1. So halfway between those is 1. That's the midline. Now, I heard Wyatt talking about this yesterday. Actually, he, instead of, like, I always find the average of these two numbers, but he just found that distance. That distance is 10, so that means the midline is down 5 from the max or up 5 from the min, and so that works. Either way, as long as you can find it, the midline is important to be able to find, because then, after you find that midline, then you need to find the amplitude. So what do y'all think for that? 5. So we can forget about A and B. And then it's all about the period. And so one thing that they might also ask you to find on the ACT is to look at an equation and tell the period. And so for this equation, the period is going to be 2 pi divided by b. What is b in this equation? Oh, the period is pi. 2 pi, on this one, it's 2. So that's the period of pi. This one, the period, is 2 pi divided by b, which in this case is pi. And that would be a period of 2. So we have to figure out, is the period of our function pi? Or is it 2? What do y'all think? Pi. Because this is half a period. Half a period is pi over 2. Our period is pi. And so choice D is the answer.
Wait, why is C 2 pi over pi?
That's how you find, if you have the equation, let me scroll back up here. This is important because I do think they ask this question on ACT also. They'll give you an equation and ask you to find the period. So when you need to find the period, it's 2 pi divided by b, which is the coefficient of theta or x. So on ours, the right answer, 2 pi divided by 2, is pi. And then the period is pi because this is half a period. So max to min is half a period. Max to max is a whole period. That we talked about that yesterday. No, the period. No. It's not asking what B is. Okay, we'll do it backwards then. Okay, so if we do this backwards, and the period is equal to 2 pi over B, pi is equal to 2 pi over B, B is equal to 2 pi over pi. So what is B? So the coefficient of x should be 2. This is the one that has a coefficient of 2. So there's 2 ways to do it. Sorry, I did it a different way. So you can either look at your choices and figure out which one has the right period, or look at your graph and figure out what the right B is. I didn't mean to confuse you. There's a lot to keep straight. Alright, so let's look at example 5. So, multiple choice questions with these graphs can get extremely tedious, especially when we do the bottom one where there's shifting left and right. It's a lot of work. This one's not terrible. So the right one should have an amplitude of 3, a midline of -1. Let's just start with that. So is there one that we can kick out that doesn't have those things? A. And so then it all comes down to the period. So when we want to, this is very repetitive, but if we want to find the period of this one, if you have the equation of the function of sine or cosine, the period is always 2 pi divided by b. What is b in this equation? So here we go again. 2 pi divided by 2. So we're looking for a period of pi. Which one? C. C is the one with a period of pi. Alright, so I want you to know there can be other periods in pi. It's just very, very repetitive in
So
this
that would
case.
have been like 3 sine 4x, or any period would be 2 pi.
Yeah. Oh wait. No. The only time the period is 2 pi is when there is no number. So just the sine of x, the period's 2 pi. If it was 4x, it'd be 2 pi divided by 4, so it'd be pi over 2. To the period, if you have the equation, is 2 pi divided by whatever this coefficient is. Okay, let's talk about shifting. Now, horizontal translations of sinusoidal functions is not called that. For some reason, it's called a phase shift, but it's the same. It works the exact same way. So if there's something added inside the parentheses, it is going to be shifted. It's going to have a phase shift of the opposite number of units, just like a horizontal translation. And so what makes this difficult is if we started right here, this would be a cosine graph, right? But if we started right here, it would be a sine graph. And so there's just so many ways to represent these. There's an infinite number of equations that is this graph. And so it's just really, really tedious. So what I would do first is see if you can just eliminate an answer. Like, we can't here, but on your homework, like if there's one that has the wrong midline, just go ahead and get rid of it, or a wrong amplitude or period, you can. However, all of these have the same amplitude because it's the absolute value of that number. All of these have the same midline, so we're going to have to check them all to see if they are the graph.
Well, it can't be a sine graph.
It could be actually a shifted sine graph. I'll show you what I mean. So let's just see about the cosine first. Let's just start with choice A. Choice A does not have a phase shift. And so whenever there's no phase shift, the period starts at 0. And then a cosine graph at 0 is just going to look like a Texas Longhorn. Right side up. So if we go to where x is 0, is this the shape of the graph starting at 0? No. So this is not the answer. All right, and then if we go to the next one, it is shifted. How many units is it shifted? Pi units shifted to the right. All right, and then this one is going to be an upside down cosine because of that negative. So starting at pi, does it look like an upside down cosine starting at pi? No, so it's not that one. All right, C is kind of tough because if we do this shift, it shifts off the graph, but we'll talk about how to do that. So this one, again, there's addition or subtraction inside. There is a shift. We're not going to start the period at 0. Where would we start it in this case? Negative pi over 2. And then it's going to look like a positive sine curve starting at negative pi over 2. Which is tough, especially because you guys don't have very much experience at all. Can you logically continue this graph to the left? Like, how do you think it would go from here to here? Can you picture it? Yeah, it would just look like that, but better. So starting at negative pi over 2, does it look like this? No. All right, so here we go. We got one more choice. Where is this one going to start? Positive 3 pi over 2. And because it's negative sign, it's going to be an upside down sign starting at 3 pi over 2. So starting at 3 pi over 2, does it look like an upside down sign? Thank goodness, it does. So yeah, very, very tedious. I think these are some of the most difficult multiple choice questions that you will have to do. There's just so much you have to remember. All right, we're going to do it all again. I'm going to let you guys choose the letters to start with. Just guess. You can make a logical guess. But, oh wait, first, let's see if we can eliminate anything, and we can't. So they all have the same midline. They all have the same amplitude and the same B value. So the only thing that's different is where we're starting and if it's sine or cosine. Anybody want to just guess?
B.
B? Okay. So let's do B. Where would B start? At pi. And at pi, it would be a positive cosine. So go to pi. Does it look like a positive cosine? Nope. It's okay. Anybody else? Okay. Where would C start? Pi over 4. It would be a positive sign starting at pi over 4. What do y'all think? Do you know where pi over 4 is? Between 0 and pi over 2. Does it look like that? Positive sign? Yay! Maybe you'll guess first when you're doing your homework. All right, now this very last example is the most important. I probably shouldn't do it last if it's the most important, but it really is. So the last question that you're gonna have, no, actually it's part B. It's the second part on your free response question 3 on the FRQ. On the AP exam is going to be a question like this. You would have already figured out the coordinates of F, G, J, K, and P when you did part A. And then what you're going to do is use those coordinates to figure out A, B, C, and D of the graph to give the equation of the graph. All right, so I am going to put some stuff on my graph. You might not need it. I'm going to at least put the heights on there. And you would have, like I said, you would have already done this. Now, does mine match yours? Because I changed it, and I can't remember if I changed. Do you have 14 for the Y on F? Okay, or the H on F. All right, and then F starts at 2. And we don't really need anything else except where P starts, which is 14. And like I said, you would have already done this work when you get to this problem. So Brian Passwater did it for you. All right, now I personally like to start with the midline. What letter, A, B, C, or D, is the midline? D. And what would you say D is? 9, good. Then I like to start with then I go to the amplitude, because these are the two easiest ones to find. What do y'all think for the amplitude? 5. All right, now we have found B a few times today. So just a reminder, to find B, you're using the equation that the period is going to be equal to 2 pi over B. We need to find the period. It is 12. And now we need to find B. So if it's okay with y'all, I'm just going to switch. And it's possible that you would get full credit for 2 pi over 12. I honestly don't remember. I can look it up. I graded some of these last year. But I know for sure you'll get credit for pi over 6. All right, so now it comes down to C. And C is all about the horizontal shift, or the phase shift. Now, today, all the ones we're practicing are sine graphs. But tomorrow, we'll also practice some cosine, and then from there, it could be either. It's going to alternate between sine and cosine. But this one, for sure, is sine, and the ones you're practicing for your homework are sine. And so, if we were looking at F, G, J, K, and P, and our curve was definitely sine, which one could be the beginning of a period of sine? K. K is the beginning of a period of sine. Because this is what sine looks like. Does that make sense? This point right here also could be the beginning of a period, but we don't know it. We're not going to use it. We're going to use what we know. We know K. So let's jot that down. Now, I said this in my last class and they got super dramatic about it, but there are an infinite number of answers for C. Now, D and A, actually A could be 5 or -5. B, only one answer. For C, it could be tons of things. So it's possible, like someone in my other class was thinking a little differently and he was right. But if we just use point K, it's 100% going to be right as long as your K is right. And so our sign was shifted K units to the right. So what do you think C should be? Very close. Oh wait, no. K is 11. Well, you want to use the X part. But not exactly 11 for C. If we're shifting to the right, it should be -11. All right, so we're going to jot that down. C is equal to the opposite of the input of point K. Oh my goodness, I keep wanting to write K so much. So in this case, C is -11.
Why is it the opposite? Is it like that every time?
Yes, because you're shifting to the right. So shifting to the right means it's subtraction. So it will be the opposite every time. All right, how y'all feeling? All right, so if you want to just go ahead and straight practice with those, they'll be at the end of your assignment. You can obviously start wherever you want to.